Experiment 1, D. Aim. To find the focal length of a concave lens using a convex lens. Apparatus and materials required. An optical bench with 4 upright, 2 fixed uprights in middle, 2 outer uprights with lateral movement. A convex lens, less focal length. A concave lens, more focal length. 2 lens holders. 2 optical needles, 1 thin, 1 thick. A knitting needle. A half-meter scale. Arrangement of the apparatus. A concave lens always forms a virtual image. Its focal length cannot be found directly as for a convex lens. For this purpose, indirect method is used, as stated below. An object needle O is placed on one side of a convex lens L1 and its real inverted image I is located, by image needle, on the other side as shown in ray diagram. The concave lens L2 is placed between convex lens L1 and image needle I. The concave lens diverges the rays and the image is now formed at I' as shown in ray diagram. For concave lens, I is the virtual object and I' is the real image. Hence, O to I is equal to U and O to I' is equal to V. Focal length can be calculated using lens formula. 1 upon F is equal to 1 upon V minus 1 upon U. Theory. A concave lens forms an image A'(B' of an object AB as shown below. The image A'(B') formed is always virtual and erect irrespective of the position of the object. Thus, its focal length cannot be found out easily as the position of the image cannot be easily determined. The focal length of a concave lens can be determined by using convex lens between the object and the concave lens by getting a real and inverted image as shown below. In ray diagram A, the rays from an object up converge through the convex lens L1 and a real and inverted image A'(B') is formed at position I1. With a concave lens L2 inserted between convex lens L1 and the image I1, image A'(B' behaves as virtual object as shown in ray diagram B. The diverging lens L2 in combination with L1 forms a real and inverted image A'(B') at I2. The focal length of convex lens L1 should be smaller than the focal length of the concave lens L2. Let OI1 and OI2 denote distances U and V for concave lens L2. The second image A'(B') is formed only when the distance between the lens L2 and first image A'(B') is less than the focal length of L2. Using lens formula, 1 upon F is equal to 1 upon V minus 1 upon U. We have F equal to U into V upon U minus V. From sign conventions, U and V are positive for concave lens. But as V is greater than U, U minus V is negative. Thus F is negative. Ray diagrams. Procedure. Step 1. To determine rough focal length of convex lens. 1. In lens holder mount the convex lens. 2. Go out in the open and face the lens towards distant tree or building. 3. Obtain the image of the tree or the building on a white painted wall, screen, and move the lens forward and backward to get a sharp image on the wall. 4. Measure the distance between the lens and the wall, screen. This will be equal to the rough focal length of the mirror. Step 2. To set the convex lens. 5. Clamp the holder with lens in a fixed upright and keep the upright at 50 cm mark. 6. Adjust the lens such that its surface is vertical and perpendicular to the length of the optical bench. 7. Keep the upright fixed in this position throughout. Step 3. To set the object needle. 8. Take the thin optical needle as object needle, O. Mount it in outer laterally movable upright near zero end. 9. Move the object needle upright and clamp it at a distance, in full cm, nearly 1.5 times the obtained rough focal length of the lens. 10. Adjust height of the object needle to make its tip lie on horizontal line through the optical center of the lens. 11. Note the position of the index mark on the base of the object needle upright. Step 4. To set the image needle at eye. 12. Follow steps 21 to 27 of experiment 1b. Step 5. To set the concave lens. 13. Clamp the holder with concave lens on fixed upright on the eye side of the convex lens. 14. Fix this upright at some distance away from the convex lens. 15. Set the concave lens surface in same manner as convex lens surface with principal axis of the lenses coinciding. Step 6. To set the image needle at eye. 16. With left eye closed, see with the right open eye from the other end of the optical bench. An inverted and enlarged image of the object needle will be seen. Tip of the image must lie in the middle of the lens. 17. Mount the thick optical needle, image needle, in the fourth upright near the other end of the optical bench. 18. Adjust the height of the image needle so that its tip is seen in line with the tip of the image when seen with right open eye. 19. Move the eye towards right. The tips will get separated. The image tip and the image needle tip have parallax. 20. Remove the parallax tip to tip. 21. Note the position of the index mark on base of the image needle upright. 22. Record the position of the index marks in the table against observation 2. Step 7. To get more observations. 23. Move object needle upright towards lens by 2 cm to get observation 1. Repeat the experiment. 24. Move object needle upright away from lens, from position of observation 2, by 2 cm to get observation. 25. Repeat the steps for more readings. Observations. On the basis of above procedure, complete the following observation table. Calculations. On the basis of above observation table, calculate the focal length of the given concave lens. Result. The focal length of the given concave lens are given above. Precautions. 1. Focal length of the convex lens should be less than the focal length of concave lens so that the combination is convex. 2. The lenses must be clean. 3. Tips of the object and image needles should lie at the same height as the center of the lens. 4. Parallax should be removed from tip to tip by keeping eye at a distance at least 30 cm away from the needle. 5. The object needle should be placed at such a distance that only real, inverted image of it is formed. 6. Index correction for you and we should be applied.